Hi there. Today we're going to have a chat about the basic configuration that I apply to all my ESPHome devices. These are very useful and in some ways vital to be able to troubleshoot and give some diagnosis. I will talk further about each one of these. Before we carry on, I just want to make a public announcement. I am going to be changing the schedule of the channel a little bit, and I think you'll like it. And I'll tell you why. I am adding a video, at least one video a week. There may be more, but that's another story. Right now, I promised you that I would do a long form video every Friday afternoon at 5 o'clock. This is not suiting me at all. I thought I could. And to be truthful with you, the way that my lifestyle is just doesn't allow me to give you a good quality video by Friday afternoon. So I'm moving everything to Saturday. That will allow me some flexibility in time to be able to give you something decent. But in the good news, there is now a new series called the Quickies. And the Quickies are going to be tutorials that are going to be under 10 minutes. They are additional to my long form videos of the Saturdays, but also they will cover installations that may be needed for the Saturday video, or they will cover things that I haven't talked about in the previous video, or questions that come from you. Before I start coding, there are a few things that I may need to highlight about ESPHome's basic configuration. First of all, there are some configuration that exists only for the ESP32 or only for the ESP8266. Well, you get the picture. These are not going to be included in this video. I will talk about the little variances between the different microcontrollers in another video, which is coming out next week, in which I will speak about Bluetooth and the web server. This said, one of the philosophies that I use in my base code is minimalism. But minimalism not at a cost of not being able to troubleshoot. So everything that I'm going to give you today is minimalistic, but will allow you to troubleshoot and diagnose problems. That's very important because these little fellows have limited memory, have limited space on them, and have limited speed. So we need to stay minimalistic, but if something goes wrong, we need to know what goes wrong. And we need to output that to the logs. What you're going to see now, every single one of my ESP devices has that in it. I call it my foundation configuration. From there, I will add other sensors. One last thing that I want to say is the ESPHome site and the ESPHome documentation is absolutely incredible. I've written my share of API documentation, and I can tell you, this documentation has never let me down. How about we start with the top, and we're going to be talking about the code step by step. Let's not delay any further and get to do some coding. See you there. How about we start? As you can see, I've taken all of the previous devices out and we are back to a blank canvas inside of ESPHome. So first thing that we're going to do is add a new device. We don't care much about this. We are going to call it Foundation. Foundation device. And we're going to click Next. It's an ESP32, and forward, I will be using exclusively ESP32s, particularly this one, which is a Node MCU ESP32 version 1.1. So let's click on ESP32. We're not really interested by this. We're going to close it, click Edit, and I am going to delete everything up to here. Now, why am I going to do that? Because I am actually going to put some code that I am about to insert. I just want to copy this. Okay, and we're going to delete it. The first code block we're going to talk about are the substitution variables. Now, we've got another name for them in coding, which is called constants. It's you set them once, and that's that. You can't set them again, you can't change them, it's over. But those are called substitution variables inside of ESPHome. Okay, so what are we going to put in there? I'm putting the device name, I'm putting the device Wi-Fi name, because the device name has to have underscore and the Wi-Fi name has to have dashes. I'm putting the device friendly name and IP address. I will talk about the device sampling time a little later, but in short, it's how many times we're going to query a sensor per minute or per hour or per day for that matter. Now, we don't want to overcrowd the MCU, because once we start to overcrowd the MCU, it's going to get slower and slower and it's going to start kicking errors. It has a limited speed and we need to be mindful of this. But we'll talk about this a bit later, possibly in another tutorial. Right now, though, I'd like to speak about the naming convention. And you will see it later. I'm just going to put up the convention on the screen for you to see. And then I'll take it out. You'll see it later. This is my naming convention. Every ID will have the device name, which is the name that we will have here. And then the sensor name is followed by that. It's underscore sensor underscore name. So a temperature sensor would be dollar, open curly brackets, device name, close curly brackets, underscore temperature. Okay, let's move on from there. Next, we're going to talk about globals. Unlike substitutions, which is set it once and then you can't anymore, you can change globals throughout the code. And that can be very useful. I'm going to use Wi-Fi as an example, and it might not be the greatest of the example, but at least it initiates it as false. And that for the log can be very useful. Now, a place where, actually two places where this could be very useful are, number one, to set a state of a sensor. Instead of getting an unknown or unavailable, you will get something that makes sense. The second one is to use into internal automations. ESPHome is capable of doing internal automations. So we can leverage from that. And you're going to ask me, okay, fine, why would you want to do an automation inside of ESPHome when you've got Home Assistant that can do all of that? Well, it's very simple. Imagine you've got a door lock with an NFC tag. If Home Assistant, for some odd reason, is offline, and your automation to open the door when it recognizes a specific tag is on Home Assistant, what will happen? It won't open because Home Assistant is offline. But now imagine that the same microprocessor is controlling both the NFC reader and the lock. And it has the ability to recognize that that NFC tag can open the lock. Well, you still can get into your house because it has the ability to do so. So these are fairly important things to think about when you start building your ESPHome device. Next is board configuration. The short about the board configuration is we are going to give it a name, and then we're going to give it what microprocessor and on which board. Now, it might not be something that you think a lot about. A lot of people will just put the standard board in there. I don't. So first, we're going to put in the basic board configuration, which you've seen a great many times, and that is the name and the friendly name. Now, we haven't changed the name and the friendly name to what it's supposed to be, so I'm going to quickly do this, and I'll see you right afterwards.
A few moments later.
I've changed the name, and a little note about my changes here. You will see that everything is prefixed with ESPHome. And you might think to yourself, well, that's pretty obvious. You are in ESPHome. After all, you know it's an ESPHome device. The problem that I face often is when I go and search for that specific device inside of the developer tools. It's easier for me to know that it is an ESPHome device because it goes and puts itself a bit everywhere. So I can start looking for all the ESPHome devices and pick the one that I want. We talked about the second part of the board configuration, which is currently missing. And this is why we've got these squiggly red lines there. But before I do, I want to just touch on a couple of things regarding ESPHome. ESPHome is two frameworks. One of them is the Arduino framework. They're actually the one that I started using originally when I was fiddling around with these things just over a year ago. And the second one is the ESP IDF, which I recently started using for some little projects. Also, there are only 5 platforms that we can use inside of ESPHome currently. The ESP 8266, the ESP32 and all of its variants, the RP2040, which is the Raspberry Pi Pico. This is still in development. So there are a lot of things there that are missing. Having said that, I have a fully functional device with light sensors, humidity sensor, temperature sensor, presence sensor, and even a screen. Moving along, there is the beacon from Libertiny, and there is the Realtek from Libertiny. I will not talk about those at this point in time. I haven't had time to play around with them. I think I may have one device that can actually take one of those two. There is also the framework. Now, the framework, I would leave to recommend it, except that in some cases for me, I've had to push it above what recommended is. Now, I don't know which one is recommended right now, but I know that I had to push to 2. I can't remember, it was 2.9 or 0.9 or something like that. And it had to do with the way that the screens work. So leave it to recommended. If that works, it works. Otherwise, go and check what the latest one is and put that. Lastly, I want to explain to you what these platforms actually do. It will define the board. And when I say it will define the board, it will define the MCU type. So for example, in the ESP32s, there are a few. There is Tensilica Extensa, there is ARM, there is RISC, and there is RISC-V. It will also define how much SRAM or memory there is. It can also, in some cases, even define how much PSRAM, which is extra memory, which is required to run a display in some cases. Which Wi-Fi type? So is it Wi-Fi 4, Wi-Fi 4.1, Wi-Fi 5, or whatever the case might be. The Bluetooth, again, same story. Is it Bluetooth 4, Bluetooth 5, whatever the story may be with that specific microprocessor. Also, what built-in sensors they are. For example, there is a built-in sensor in the Pico that doesn't exist in the ESP32s. In the ESP32's, temperature will actually give you the temperature of the ESP32 microcontroller. There is an actual temperature sensor on the Picos that you can access. And that will give you environmental temperature. It will also give you how many SPIs, I2C, I2S, and UART you have available to you. It will also define the GPIO pins, which one you can use, which one you can't use, which ones are for SPI use, which ones are I2C use, and so forth. And that was just to mention a few things. So I do generally try to get the right board. And if you want me to expand on that, please leave a comment below and I will show you where I find these things in a quickie. Okay, so let's move on. Here it is, ESP32. The board is an ESP32 dev, which is this, and the framework is Arduino. Now, there are a couple of things about IDF and Arduino that I need to quickly chat about, and that has to do with certain things are not compatible with the other. I know that, for example, the web server will work fine on the Arduino framework, but not on the ESP IDF. So, or I should say the IDF framework. So you got to know these little quirks. I do believe that in the case of the web server, it has been ported. I think that Nabukasa is trying to get the two of them aligned. Funny enough, the Arduino framework for ESP32 is based on the IDF framework. The next piece is logging. Now, I'm not going to hop much around logging because, well, we're trying to limit our time here, and this is possibly going to be a long video. Logging. And you will see there is a lot of options. Now, I do not put this as a standard on my devices, but I wanted to talk about it nevertheless. There are different logging levels that exist, and you can go to the ESPHome documentation to find that. Info is in between. So it's not verbose or very verbose, and it's not just, sensor data. If there is an error, it will show it at info. Having said that, you don't need all of that. This is perfectly fine because that is the default for info. The next one that we're going to tackle is the Home Assistant API, and there I have a few things to say. Recently, I had a question on my personal GitHub regarding this. And the question was, why can't I get any data on my ESPHome from Home Assistant? And this is why. If this is not right, if this is not correct, if you do not have an API key, you will not talk to Home Assistant. So you will not be able to extract information out of Home Assistant. You will not be able to synchronize the time from Home Assistant. In fact, yes, it will see it, but you won't be able to initialize it properly in Home Assistant. I think I've covered that quite well. And the code is very simple. API, reboot timeout is 0 seconds. So basically, it will try to get as soon as possible a connection with Home Assistant. The encryption key is over there, and we've talked about key exclamation mark secret API encryption key in the past. It's in the secret file. And as I've told you, I do not use multiple keys. I use a single key for all of my devices, a single password for all of my devices. And this is just because I can't be bothered remembering 30 odd devices passwords. Okay, So don't worry about the squiggly lines. They will disappear in time. It has to do with the fact that there are other things that are missing, like Wi-Fi. So we'll move on, and I'm going to talk a bit about over-the-air updates. They will disappear in good time. This is possibly why I absolutely love ESPHome. Over-the-air updates actually prevents more gray hair. And as you can see, I've got my share of those. First of all, we enforce safe mode. What happens is that once it has acquired the update, what it will do is that it will reboot into safe mode, canceling all connections, canceling all unnecessary goodies, and it will focus on updating itself. Once it's updated itself, it will immediately reboot. But in the event that it doesn't, we're going to put a reboot timeout of 10 minutes. That will restore the old version, reconnect, and we can try to repush again. That's assuming nothing is corrupted in between. The number of attempts would be 5. So it's going to try 5 times to do the updates before it gives up. The password? Well, I use the same password than my web server. There you are. Now you know everything. Again, all my devices use the same passwords. There is a reason for that. My brain is not meant to remember all those passwords, and they are highly complicated. Trust me, I use 16 characters with special characters, with numbers, with whatever else you can think. Now comes the big one, Wi-Fi. And as I say in my notes, what would be an IoT device, Internet of Things, if it wasn't connected to a network? Well, it would be pretty useless. Some of the examples of connectivity that we've got available to us on the ESP32 and inside of ESPHome are Wi-Fi, Bluetooth, Ethernet, LoRa, ZigBee, RF. I haven't used LoRa, ZigBee, and RF inside of ESPHome, but I do believe it's possible. I haven't used Ethernet, but it is part of the core networking system of ESPHome, so I'm not worried about that. So let me show you the configuration first. Here it is. Before we even look at what's below here, and the only part that you really need is this section. So Wi-Fi network, the SSID would be your Wi-Fi access point name, password obviously for that Wi-Fi AP. So if you use it like this, DHCP will then give it an IP address. You will have to go to the logs to go and check that IP address. Now I keep all of my IP addresses in a spreadsheet, and I know where every single one of my devices is and what it is. That allows me to also troubleshoot my network should there be a problem. This is why I use manual IP addresses, because I know where the device is, I know what it does, and I can also know if something is trying to intrude in my network. So here we are. This is my foundation configuration for Wi-Fi. Although I need to be honest with you, because my devices do not go outside of my network, I do not use DNS. I seem to have a problem. Device IP address is not recognized. What have I done? Oh, you see, device IP address is incorrect. I completely forgot to update it, and I hope you were all screaming at me. So it will be 0, and for today we'll use 160. And I'm going to go back over here, and all the squiggly lines are gone because now there's a network. Let's talk about the next block here, which would be the AP block. Should it fail to connect to you a valid and known access point, what it will do then, it will become an access point that you can connect to. And the SSID is incorrect. So I'm going to go and correct it. Give me a second.
A little longer than a few minutes later.
All fixed. As you see, I'm using one of those substitutions in this case, which is the Wi-Fi name. To come back to what I was trying to say, In the event that it cannot access a access point, a Wi-Fi access point, it will then become an access point itself that you can connect to. Now, there is a caveat here. Don't try to use this with a Pico. It just doesn't work properly. In fact, with the Pico, the captive portal doesn't work either. What the captive portal does is it allows you to set a access point. So you could theoretically not have any Wi-Fi details whatsoever. I've never tried, I'll be honest, but no Wi-Fi detail whatsoever, and just use the captive portal to set your Wi-Fi details, and voila. So that's for the Wi-Fi. I think I've covered most of the things. Oh, yes. Let me check my notes. I have forgotten one thing. If it goes into captive portal, you will have to connect to it using the Wi-Fi details that you have set here in the AP. So the SSID would become basically the name of the device, and you would have to use that password to get onto the Wi-Fi, and then you would have to go to HTTP 192.168.4.1. I will show it nicely over there. Okay. Next in the list is web server. Now, I've talked about web server in the previous video. Web server is a great diagnosis tool, and unfortunately doesn't work with the Pico. And I have no idea if it works with the Realtek, but it works 100% with the ESP32 and the ESP8266. A little thing about the web server. Number one, the port is 80, which is a standard HTTP port. We're running version 2. We are including the internal variables. Now, the internal variables are not reported back to Home Assistant, but they are reported back to the web server. So it's an extra little thing to allow you to diagnose your problem. Obviously, there has to be authentication to get into it, username and password. And then local true is it puts the JavaScript onto the device. Why would you want to do that? My devices do not talk outside the network, so I want it on that device. Next is the status LED. It is debatable if it's useful or not. Personally, I use it to see if it connects to the network properly, to the Wi-Fi properly, then I kill it. This is how I do it. I assign the pin where that specific LED is, and then I invert it because I don't want to see it. Now, it's odd because sometimes you have to invert it and sometimes you don't. It depends on the board. You'll just have to play it by ear and check. Usually you'll see it blink a few times and then go quiet. You know that that board is a false. Otherwise, the light keeps on thereafter, and that's the truth. I will want to move on to the time. Now, there are various ways to get the time onto your IoT device. These are SNTP, which requires internet access, or the IP of the SNTP server. I do not want my devices to talk to the internet, therefore this is never used. The next one is GPS. If you've got a GPS sensor attached to your ESP32, you can get the time from the GPS. Another one would be RTC. In the case of RTC, or real-time clock, you will require RTC hardware and ideally a battery to keep that RTC clock from drifting, number one, and from disappearing, number two. Now, I don't use RTC, and I do know, for example, that the Pico has a built-in RTC, if memory serves me well, and I don't use it. I don't use it for a simple reason. Home Assistant gives me all of that information. And even if Home Assistant suddenly decides to disappear, the internal clock will still carry on as long as it's got power. It's when it doesn't have power anymore that it will reset. The code for time with Home Assistant is really straightforward. There it is. time, platform, home assistant. Now I want you to remember for the future that platform home assistant, because it's going to be very important in other things that we're going to do, like getting other information from home assistant to us in such a way that we can actually use it within ESPHome. For displays, this is extremely important. I think we've got this one down, and I am going to then talk about our first real sensor. And the first real sensor that we're going to talk about is a binary sensor. Now, a binary sensor in layman's term is on or off, true or false. That's all it does. It can be very useful though. So this binary sensor gives us the status of the device. It's not a required sensor by any means. However, what it does in Home Assistant is that if it's not available, it will tell you false. And you could kick off an automation saying, hey, I got a problem here. This IoT device is no longer with me. There is value in it at the end of the day. We're going to move on to a whole bunch of other sensors inside of the ESP32 that are pretty useful. They are focused on diagnostics, and they are focused on things that will give us the ability to troubleshoot. The first one of these has got to do with Wi-Fi. This is my sensor section, and the first one is Wi-Fi signal. How is that useful to us? Well, if it's too far away, the signal will not be strong enough. And just to give you an idea, I have a little list because I do not remember this off the top of my head. But in short, and maybe I will put it over there, anything that is greater than minus 50 dBm is excellent. Anything that's in between minus 50 and minus 60 dBm is good. Anything that is in between minus 60 and minus 70 is fair. And anything that is below minus 70 is poor. This was our first one. The next one is a bit more complicated. First, I'm going to give you the very basic of it. Uptime. Now, uptime is I started 5 days ago and I'm still going strong. This is what that sensor gives you, but it gives it to you in seconds. Now, I have some of my sensors that have been running nonstop for I don't know how many thousands and tens of thousands of seconds. Do you think that I know how many days that is? Yes, I could go and punch it and calculate it. Sure. But to be honest with you, there's code for that. And let me give it to you now. There we are. It's failing. And let me tell you why. It's trying to publish the state here to this sensor. And this sensor over there doesn't exist yet. So again, just to tell you how far they've gone with the editor of ESPHome, again, it shows us squiggly lines, something is wrong. You're not too worried about that right now. This here is the state that is going to send back. And you can see we're getting this, the seconds translated to days, the seconds translated to hours, the seconds translated to minutes. And with that, it becomes far easier to read. And I'll show you that a little later. Let's move on and let's talk about another type of sensor, which is the text sensor. Now, the text sensor gives you output text, whereas the sensor can output integers, can output dates, which is technically an integer, can output a few other things. Now, text sensors are slightly different. As I said, they output text. Now, why would you want to output text? Well, let's take the Wi-Fi information for example. We would want to know which IP address we are on, which access point we are connected to, and even the MAC address. Now, why would you want to know the MAC address? Well, if you don't want to assign an IP address inside of ESPHome itself, you could go to DHCP server and assign the address there. To be able to assign an address on the DHCP server, you need the MAC address. So let me show you this code. There is the code, text sensor, and as promised, the first part of it is the Wi-Fi information, including the IP address, the connected SSID, and the MAC address. The second part of the text sensor here is the ESPHome version. Not strictly needed, but it's nice to know on which version you are. I have some devices that are not up to date, and yes, ESPHome will tell you so, but you can also report it inside of Home Assistant and say, whoa, I do not have that done. I don't have an automation that does that, but it does help me knowing where I am in the updates. And lastly, we've got another one that I was talking about earlier, and that would be the Uptime Human Readable Sensor. And where have we heard from that before? Right here. This is the one that we're using. So now we've got that sensor as well. And there is just a couple more, and I'm hoping that this video will not be too long. For the next one is our default switches, which are switches that are part of the ESP32. And these switches are restart and restart into safe mode. Now, restart can be useful in some conditions, particularly if you want to be able to restart from Home Assistant. Restart in safe mode will help you troubleshoot things. I've never had to use it, but I'd rather be safe than sorry. By the way, if you ever wonder what anything is for, there is a little tip. Hover over it. It will tell you. As I say, they've done an amazing job on the documentation, but also they've done an amazing job with the editor. The last piece is the intervals. Again, not strictly needed. I use it for the Wi-Fi. So as you've seen earlier, the Wi-Fi was set to false initially. And what this does is that it checks the connection all the time. So are we connected? Are we not connected? Are we connected? Are we not connected? And it sets it accordingly. That's all this does. That's the entire usefulness of this. And again, this is useful when you've got a screen. Not so useful without it. That concludes the configuration file. Now we need to compile it. We need to see if the debug works. Then we need to add it to Home Assistant and see if it works in Home Assistant. So let's compile it. First things first, let's make sure that the device is plugged in. Sorry, it doesn't focus. Let's hit install. And like I showed you previously, plugged into this computer, and it will tell us that ESPHome is not running in HTTPS, but it will still compile it, and it takes a minute. I will fast forward.
A little longer than a few minutes later.
It has compiled. We can download the project. Here we go. It's now downloaded. We can open ESPHome, and you will see this is HTTPS web esphome.io, so it's HTTPS. Therefore, it should work. We are going to connect. Again, you can see it's the USB 2 serial. We're in, and we're going to say install. We're going to click on the bin file, the firmware, drag it and drop it. And we're going to say install. Again, this might take a second. What I love about this is obviously that it's erasing it first. I'll fast forward through this.
A few moments later.
Well, it has finished installing. We're going to close this, and we are going to close ESPHome, and we're going to close this, and we're going to close this, and we are going to wait for a second. And we are now online. First thing that we do is we check out the logs. So we are online, everything is working, and there is the first data sent. It will send it at a regular interval. Now I'm going to visit and make sure that the web server is working. As I've said, they all have the same password, but it is a complex password. As you can see, relatively long. Unlike last time, we've actually got data. Now we know that we are logged on to an AP called VR9-IoT. We know that we've got ESPHome version 23.12.9. We know that we are running on IP address 192.168.0.16. I'm not going to read the MAC address, but we have two switches. One of them is called restart, and the other one is safe mode. Uptime is 1 minute 49 seconds, and you can see the uptime sensor is at 109 seconds. Lastly, we've got the Wi-Fi signal sensor, which is sitting at 51 dBm. Now, if I check my list, 51 dBm is good. And then we can also send a file for update. And over here, we've got our logs being sent. We will then close this and we'll go to device and services. It hasn't picked it up. So what do we do in a case like that? Well, let me show you. We go to ESPHome and it's going to ask what host. And our host here is 192.168.0.1 and we said 60. This is where the magic happens, the encryption key. Without that encryption key, Home Assistant will not talk to the ESPHome device, will not talk to the Home Assistant device. So I'm going to have to go and get that offline. I'll see you once I've got it.
A few moments later.
I entered my API key and I clicked save. And here we are. What area are we in? Now, this is a foundation device. This was a demonstration, so I'm not going to put an area to it. I will talk about areas in a future tutorial. I'm going to say finish. And now we are going to have an ESPHome device inserted over here. And you can see there is one device with one entity. Now, if you ever end up in this situation where there is one device with one entity, there is only one thing that I can recommend to you is to wait for a minute. And once you've waited for that minute, go back and refresh. And voila, we now have it inside of Home Assistant. Let us recap what we've learned today. We've learned what we should be putting on every ESPHome device. It's not a complete and exhaustive list. However, it's a good start. We've compiled it, we've checked the web server, and we added to Home Assistant. I think that wraps off today's video, but before I do, a few things more. I'll explain the issues with the web server and how it clashes with other sensors in my next long-form tutorial. This starting configuration has never let me down. So use it, don't use it, that's your choice. I'll wrap it off here. To make sure that you don't miss any of my tutorial, will you please click the like button to let me know that you like what I do, subscribe, and if you really want to know when the next one is out, hit the notification bell. This is Pascal signing off. See you in the next one.